We will see the remaining four parts. Yesterday we have discussed there are 7 parts in the snake game, where we have seen about all the first 3 parts. Now we will be doing all next 3 parts coding. Uh, so we have already coded like create snake body, and we have created how to move the snake and how to control the snake with with the key presses from the user. Now we will be creating food, and we detect once the food is there, we will be creating on the same screen how the fruit should be. There are few basic steps have given, so we need to create another food .py and create a food class which inherit from the turtle class, and we need to define the shape and size. For example, we can, as of now they have given a circle and size to be smaller, like generally the a turtle size will be turtle object size what we created will be 20 by 20 pixels. So if you want to uh, create a less pixels, then we need to use the shape size function method, you can say. And now we need to create a food turtle object on the screen, and we need to place it at random objects. And every time snake hit the food, we need to create another food object, and it should be created at random. So how we will be creating, we need to, they have given in the distance method. Similarly, the snake should once the snake should hit that, then generally it should increase its size, whatever we already played in uh, uh, games. So what in our childhood. So for example, let's see how we have already coded. So the final output will be something like this. So now Python. So it's my game is over because it detected the collision as of now. So we will say it's like it is at 280 pixels. We can change it. Uh, no, generally, okay. Let me rerun again. So if you see, it got increased its size. So I am playing with arrows. Now my game got over. My score is 6. So we will be coding one by one. So now generally what we inside this food.py, so we need to create a food.py file. So yesterday we have created mine.py and snake.py file where we have used the oops concept. Similarly, we will be creating food.py. So if you see this now, generally we are importing the turtle class. From the turtle class, what we are doing, we are as they have defined, because they have given us a hint, because we need to use all the methods or all the uh, attributes whatever defined, or you can say variables defined inside the turtle class. We need to use the same for the food class also. So that's why we are inheriting from the turtle class. So we are defining a constructor method, and here the super keyword we are using, what we for from this, what we are saying is we need all the declarations whatever defined in the turtle class, we need that as well, so that my super class, So my superclass of food class is turtle class. So all the constructor or all the methods what are defined in the turtle class, I can use the all the methods and all the variables are defined inside that. So generally, if you see the snake class, so we have created a, for example, let's see this one, the turtle and the color, the pen up, the go to, similar kind of stuff we will be doing. So now what we are trying to do is we are creating shape. Shape is already defined attribute from the this class. So, but what we are doing here, whenever we create a food object, it by default the constructor method what it will do, it initialize the turtle object, and then the turtle object shape will be a circle, and then we don't need any drawings like pencil lines, so that's why we are doing pen up. And then this is the main thing. So here we can give turtle also whatever we like. So shape size is like how much generally it will be one by one. Like if we give one, it will be 20 pixels by 20 pixels. So length and width, what we are doing, we are dividing by half. So we are giving the object, for example, the food object or food turtle object as 0.5, 0.5. So it's like 10 by 10 pixels. And here the color we can define whatever color we like. Uh, for example, we have defined blue. If we do the red, we can do, and the cursor object like animation, right? So whenever the food object got created, it should be very fast. We don't need any animations to that. So okay, this object created here and this object created here. It's like we don't need any animation kind of stuff like where user can check okay this is doing going from here to here. We don't need that, so that's why we have kept the cursor like turtle object speed to fast. And then we are again this is like the method. If you see here, we are defining a refresh method where we are doing a random. So it's like once if we go back to this, we have created all first three steps. Now we will be doing, we have to keep the foot object random on the screen. So that's what we are doing. We are doing a refresh method. Now what we are doing, generally our screen size what we have defined is 600 by 600. So it's like 0 to 300, 0 to minus 300, and 0 to like x-axis. If you 0 to uh, again 0 to minus 300, 0 to 300 like y-axis. Similarly, but our snake pixel like segment in the snake is generally the title object is 20 by 20 pixels. That's why we are reducing a 20 pixels in that. So we are just in this range. This x-axis will be selected like random integer. So in this range, any x coordinate will be selected depending on random function. So similarly, the random y coordinate also will be selected using this. And now what we are defining, we are saying that food object, food object is nothing but the turtle object again. To go to this, whatever the we are getting from the random positions, we need to go to that. So here what we did, we have changed the color to red. Let's see if we run again, what color it comes. It's not coming. Red. Sorry, I haven't saved. So now it got red. It's very difficult. Finally it got. So we are using random, so just okay, because it got touched to wall. So we have defined the food object. So yeah, so we have detected this. Up to here we have coded in the food.py, but how we are coding, like how we are detecting when the snake hit the object, we need to increase the snake size. So what exactly we are doing is, if you go to make main.py, so now what exactly we are doing, head is like the segment 0, right? We already defined the head is the segment 0. So if you go to snake.py, self.head is self.segment of first, whatever the segment we are creating, in that we are creating head. So in the snake object, if head dot distance, so it's like the distance is another function in turtle. So if we are giving two turtle objects, so it will return how much distance it is there. So between that now turtles instances. So on the screen we have two turtle instances, right? One is like our segments with our snake segments. We can snake object, and another is food object. So now we are actually doing, if the distance between is less than 15, so we can, this is a trial and error number, we can change it to like a 10, or depending on whatever require. So the once the distance between the segment and uh, the food, if it is less than 15, we can change it to 12, or then what we are doing, we are calling the food to refresh. So again the food refresh is like, now it will create another object, like another food at a random position. Then once it is done, now the next important part is we need to extend, once our snake got hit, we need to extend the like snake length, right? Then what we need to do, we will go to this one, where yesterday what we had defined, let's see, yesterday in this we have defined everything under a create snake and self, like a create snake method, where for position, starting position, we have created all the three segments. But here we need to create another segment when snake hit the food. So what we are doing, we will be just defining another method, add segment, and it's like we are giving argument as position, So the same, for example, all these steps we are just moving into another method, add segment. And for create snake, it is like for same the position, just we have called this method in the snake method, create snake method. So it will create all the segments, like it's like creating running this function. You can say I'm calling method, for our understanding we can say it's function. We are calling this function three times for that, because we defined only three positions here in a list, so it will call three times. but but it got once our snake hit the foot, right, we need to extend it, so we need to create a new segment. So how we will be doing that? We will getting segments from segments list, what is the last position. So we can get the last index, last item, right? So if we given -1, it is like the last position. For that last position, like whatever the segments. So if for example the first three segments will be this, like, so once the snake moves, so this will obviously change. So like three segments will goes on changing. So we are getting the last segment position, and then we are adding with that position, wherever the segment last position is there, taking that position and we are adding segment into the, like, the segment list. So if you see, then we are actually what we are doing, we are just creating another segment, and we are adding that segment to the segments list. So it's like new segment, color white, like the same thing, like what are the positions we defined. So now the last segment, when the snake is moving, at which position it is there when it hit the foot, then the last whatever the position is there, we are getting that position using this method. Yeah, and then we are adding that segment to that position. So it's like we are generally it is three segments at starting. Then now once it got extended, now what it will do, it will go to four segments, and again. So if we just don't consider this, so it will extend whenever the foot got hit, the segments in the snake will be extended. So for user for user, what it thinks, the snake size will increase. So what exactly we are doing, we are actually adding the turtle objects into turtle objects. So we call it as segments of the snake to extend. So we are creating a new segments, so that the snake will be displayed as more segments, like it goes on increasing depending on the whatever the food uh, the snake hit. Now this is complete. So now if we go to the next step, so now we need to create a scoreboard and create a similar kind of stuff. If we go to here, so now we are actually again doing the same thing from import turtle. Just let's forget about this. What we are doing, we are again initializing a constructor method. So we are again creating a scoreboard class using turtle as super class, and from the super class we are actually defining we want all the all the variables, whatever class variables, instance variables, and all the methods defined in the turtle class should be accessible by us as well. So that now what we are doing, self dot score, just for example, like we need to display the score. So for, at starting, obviously it will be 0. Now again the color we are displaying as white, we can change it to our own color. So for example, if I change to blue, and then what we are doing like we don't require that line draw, so we are saying pen dot up, and then what we are doing, go to we are creating the object to go to there, and then like hide title. So generally our title thing, whatever we created, it will be in arrow or whatever the shape. Generally by default it will be arrow. We don't want that to be shown on the canvas or the screen, so we are hiding the title for displaying the scoreboard. So now what it is, how we are doing is, there is a write method where we actually do a write whatever, it's like a print statement, but uh, for title, so we will be using write, similar kind of stuff. So we are using f strings. So score is self dot score, like this is the variable. So if you see, this will be score of 0. Now these are the alignments, like where it should show and what are the font. We can change this everything, like there is no issue. So if we see the syntax, right, so argument objects to be written to the title screen. So it's like printing the objects to title screen. And move, so we don't know, by default it will be false. So align like left, right, center. So and font should be in tuple. So we already discussed tuple. So it's like Arial, screen size, like font, what are the size, what is the font type, and font size. So similarly we are defining similar, like Courier, the font size is 24 and it is a normal font type, normal. So it's like italic, bold, whatever we require. So as of now, let's focus on only this function, update score. But we need to update score whenever uh, user has eaten, like the snake object has eaten the food, right? Then we need to update the score. Generally we are just showing this one. So what we are doing, we are actually increasing the increase score, like score to +1, whenever this function will be called or the method will be called, and then we are displaying the like scoreboard on the screen. So what if we don't clear this one? So this is one of the main method. So what it will do is, if we don't give that and if we try to run it, so if you see here, it is overriding, like you can't see correctly, right? On 0 it has written 1. If we go to on the same thing, it will write 2, 3, 4, whatever we like. So it is not actually clearing the screen. So that's why it is just imposing whatever the whatever we are giving, it is just imposing on the same turtle right object. So that's why it is like imposing. So that's why what we need to do, we need to clear the screen before incrementing, and before calling the update the function to show, we need to clear that. So the same thing like rewriting. Now this the same. Now the step 6 we will be seeing like once the snake hit the wall. So again we have defined depending on x and y coordinates we need to get the x and y coordinates of the segment, and we need to display game over. So similarly what we are displaying like score, similar kind of stuff we need to display game over when the our snake hit the wall. But again this segments conditional logics we need to define at which point it should break. So if we go again to our main.py function, here what we are doing, we are detecting the collision with the wall. So how we are doing, we are if head, so at head is like the segment, first segment, we are getting the first segment x coordinate is greater than 280 or uh, and x coordinate is minus 280. So it's like we divide into quadrants. So it's like whenever the head is at minus 280 degrees or this minus 280 pixels, because we are defining 600 by 600 screen size, and this will vary depending on our screen size. So if we give 800 by 800, we should minus 20 degrees like 20. So it will be 800, then it will be 380. So generally it will be 400 by 400, so it will be 380 by 380. Or we can increase also. So if you want like 290 by 290 also we can give, or just if going still further then. So it's again depending on our whatever we want to check. So if you want to hit total the wall, then you can directly give 300, but better because already the snake has 20 pixels by 20 pixels width. So that's why we are giving 290 just to check how it behaves. And what we are doing, we are doing the game is on to false, so then the loop will end. At that time what we are doing, we are just calling game over method from the scoreboard method. It's just nothing but again we are just that creation of object, scoreboard object already created, and then what we are doing, we are just going to this 0 comma 0 the center location, and then we are just writing game over. So alignment and font will be same. So for the object, the screen object, like the scoreboard object, whatever we define the color, it will be at this one. So now again, if I try to run, so before that it's like when it's now just few, it's very nice to see like it says almost got hit in the wall. But if we give 280 pixels, right, then what it will happen, it will have some space. We can see that space as well. Like let's see. Now I given 280. So here, because y less than 280 means, so the angle is like, if it is crossing minus 280, so minus 290 is less than minus 280. That's why we have given less than symbol. Similarly for y coordinate also. So again, if I run this, just I am saying, as of now there is not much difference, but generally, so yeah, here if you see again, so it has hidden this 280 because there is some gap. Before we have given 290, but now it is like 280. So we have seen there is very much gap, but still the game got over because it has detected. So this variables, this coordinates we can change, and we can just reduce this size also if required. You can check how we can reduce that size. So the final part will be similar kind of stuff. We need to detect a collision with tail, but how we will be doing that? So generally, what we will be do, our logic is like, we will for segment. So in the segment, we are storing all the turtle objects what we are creating, right? So we are looping over that list in snake.segments, and we are just checking if head snake head dot distance of segment is less than. So it's like from the snake head and the segment what we are checking, if it is less than 10, it's like almost hitting, right? The distance we have checked, we already checked, used this for food detection. Similar kind of stuff we are checking for the segments, whether the head is actually, the distance between the head and the segment, the second segment is less than 10, then obviously it's like it already hit that, then we should call. So, but why we are passing this one? Let's just I'm commenting this out. If we don't give this, so whenever we start the game, so whenever we start the game, it is almost done. So by default, it is game over, because what it is doing, it we are checking the head first, for the head, and the first segment in the in this list is head. So so it's like the distance between head and head, obviously it is 0 only. So we are checking with the distance of head with the distance of this one. So that's why it is actually always it this condition evaluates to true. So that's why it is failing. So we need to bypass that uh, thing. So that's why what we are doing, we are checking if the segment is equal to snake dot head. So it's like if the segment is equal to snake dot head is like, if segment of 0 is equal to segment of 0, then we are not doing anything, like we are just passing to the next condition. Else if now we are doing elif. Now the first segment is generally, we are skipping the first segment, then when we go to the next segment, and if the distance is less than 10, then we are doing the game to end, and then we are calling the game over function. So this is one way, and other way we can write is like we can give uh, like list slicing. So if we give like this, so we are just uh, displaying except the first from the index 1 to the last, we so we are excluding the first segment, so at that time we don't need to write this. So if I just comment it out again, so we are just looping over, so it's like in list slicing, so we are excluding the first segment. Now it should also work fine. Now game over, it's working fine. So either we can write like this or this one. So better we will be using the list slicing method so that it is easy, and it much code reduction will be there. So instead of writing again this conditional statements, we just saying to slice it out, just start from the index 1 to last, so it's like index slicing. So if you don't give any number, so it will slice till end. So if we given some index again, so it will slice up to that index. So yeah, that's it. I think we have done snake game. Yeah, we can play using the snake game. So yeah, you can do your own modifications. You can for food you can give a turtle whatever you like. So for example, whatever you like, and you can just increase food size also depending on your requirement. You can increase screen size, and you can increase uh, depending on your requirement, or just if you want to do trial and error. So instead of square, if I given turtle, so it's like snake eating turtle. If you see, yeah, now I'm snake is eating turtles. Done. So you can try with various shapes. Yeah, we'll be sharing this code. Mm, Not, that's it for today.